Welcome all for the video tutorial on machine learning, and today's session will be continuing with our fourth module, which is Bayesian learning, and we'll see the eighth session, that is the last session of our fourth module, which is EM algorithm. We'll see what is EM algorithm. It is nothing but expectation maximization algorithm. EM is abbreviated as expectation maximization algorithm. Okay, why do we use this algorithm? Where do we use this algorithm? In real world applications. Okay, most of our real world application, which is involving machine learning, has only small subset of observable data. Okay, we here take a few real-time examples, or most of our real world examples are relevant only with small subset of observable data. So when we in that subset of small set of observable data, it is very difficult for going for class, either for classification or prediction. So we use this expectation maximization algorithm in order to have a better efficiency of the algorithm. Okay, here we use this algorithm for many of our unsupervised clustering algorithm. Okay, here what we are going to do is, it is going to estimate the maximization of the maximum likelihood of the algorithm by implementing few concepts of probability. Next, we'll see what is the steps we have in the EM algorithm. So, the EM algorithm, we have two main steps. So, mainly we use this EM algorithm whenever our data sets are incomplete or whenever we have a missing data. In real-time application, most of our application will not be a complete data set. Okay, we have an incomplete data set there, we have a missing data sets there. So, to fill up that gap, okay, so when you have there, it is very tough to obtain the efficiency when you go with the missing data or an incomplete data set. So EM algorithm provides you a prompt to overcome the drawback that we face. Okay, and in EM algorithm we use two steps. Okay, two steps are mainly used in this EM algorithm. The first step is E step and the second step is M step. Okay, and in E step what we are going to do is, we are going to update the hypothesis. We are going to update the variables. Okay, we will be using the observed data, and we will be using the observed data in the data set, and we will be estimating the value which has been missed. Okay, you will be estimating the missed value by observing the available parameters in the data sets. Okay, with the help of the available parameters in the data set, we will be estimating. How this estimation is done? By guessing. Okay, by guessing. So if you have 5 features, if one feature is missing, we are going to relate the other 4 features together, and we are going to try it. We are going to analyze which is the missing word. Okay, usually this we see in most of our real-time applications. When you search something in Google, what happens when you type 3 words, the next word it will be there in a Dropbox list. How? Because that is what, from this 3 words or 4 words, it is going to correlate that, and it is going to detect what is the next data that is supposed to display. The same concept we have here. This is done using this E step. Okay, how it is done? With the given data available in the data set, it is going to either predict the next data that is supposed to be there, or it is going to identify the missed data set. This is the first step. The first step is the E step, and in that you are going to update the variables. What variables you are going to update here? The missing values. Okay, how do you update the missing values? By with the help of the available data sets, you are going to predict the missed data. Okay, this is what your E step is, and that is followed by M step. In M step, you are going to update your hypothesis. So what we did in E step? In E step, we have detected the missing data. So with this missing data, you will be able to evaluate your hypothesis. So that updating of your hypothesis will be done under the M step. Okay, and you'll be repeating these two steps in this algorithm. In EM algorithm, these two steps, expectation step and maximization step, will be repeated until you have a convergence. Okay, until you have a convergence, you will be repeating it. Okay, this is the flow chart of EM algorithm. First you have a start and you have an initial values. Okay, and in that initial values you may have few parameters as missing data. Okay, in initial values you have data for the data sets, and among that data sets few data will be missing. Okay, then with that will be given to your expectation step. That is the first step of your EM algorithm. What do you do in the expectation step? You are going to predict the missed data. Okay, you are going to predict the missed data with the help of the data which are available in the data set. That is what you are going to do in the expectation step. Then you are going to do the maximization step. The next step, E step, is followed by the M step. In maximization step, from the data you have observed in the expectation step. Okay, you have analyzed the missed data, and from analyzing that missed data you are going to again convolute. Okay, you are going to convolute with the updated parameters. Okay, in the first expectation step you will be able to find out what is your missed data, and with that missed data you are going to implement in the next maximization step, and the output of that, if that output is converging. Okay, if it is converging, then you will stop, or you will be repeating the steps. You will be repeating the steps, two steps of expectation step and maximization step. In expectation step, you will be finding out the missed values, and in the maximization step, you will be converging with the obtained data from the expectation step. This is the general flow chart of your EM algorithm. We'll see the working principle of EM algorithm. As we have discussed already, we have we have two steps. Okay, we will be implementing this from a specific, we will be choosing a model and we will be implementing an algorithm, EM algorithm, in that model. Okay, you know what is the first step? Expectation step. The other one is maximization step. Okay, and you update and convolute with these two steps. What we do in the expectation step or E step, we will be detecting the missing data. The missing data will be observed. Okay, we will be finding the missing data with the help of the data which is available. With the available data, you will be predicting the missed data. That you do it in expectation step. And in the maximization step, with the analyzed data in the E step, we are going to convolute. If the convolution takes place, we'll go for the output, or you will be repeating your expectation step and M step, maximization step, until your model converged. Okay, and until it convolutes, you will be repeating both the two steps. See, here is one example for EM algorithm. Okay, we have data of observed data and unobserved data, and we are grouping that. In the given data, we are going to group them into two types of data. One is observed data, other one is unobserved data. And the observed data we are representing through X, and unobserved data we are representing through Z. And these are all the 5 features we have: sinus, flu, allergy, headache, and nose. These are all the features we have. And now, under this flu, allergy, headache, and nose, maybe it is of running nose condition, all this comes under observed data, and sinus is the unobserved data. So in the unobserved data, with the observed data, you are going to predict the unobserved data. So what are all the observed data? Flu, allergy, running nose, and headache. These are all the observed data. With this observed data, and we have an unobserved data, sinus. With the help of this observed data, we will be predicting whether the patient has sinus or what. Okay, that we do this with the two steps. The first is E step, and next is M step, and we use the formula here. Expectation EM algorithm, probability of Z, that is the probability of achieving your unobserved data, will be the log of probability of observed data given the unobserved data. When you implement this formula, you will be able to predict what is the probability of you will be converting your unobserved data. That is, we will be able to predict what is the occurrence of a flu for a given condition or for the given data set, whether the patient has sinus or what. The sinus is an unobserved data. With the help of observed data, you will be validating it. This is all about EM algorithm. Thank you all.